In this video, we want to talk about differentiation of implicit functions. An implicit function is a function that is written in terms of both dependent and independent variables. If, for example, we have to find the dy dx of x squared plus y squared equals 4 at 2, 1. Now you can see that both x and y are written the same place. What we're going to do is we're going to differentiate this with respect to x, and we're also going to differentiate this with respect to y. In other words, what we'll have is, if we differentiate this, 2 times 1 is 2. So we'll say, we'll differentiate this, you have 2x dx plus, if we differentiate this, we'll have 2y dy, and if we differentiate this, is 0 since it is a constant. Now we're going to take y on one side because we want to find the y being on top and then the x being down. So let's have dy 2y dy will be equal to, taking 2x dx on this side, it will be negative 2x dx. Now we can factorize this and bring out dy out. If we factor out dy, we'll have 2y will still the same. It will now be equal to, factor out this as well, dx into minus 2x. Now we can divide both sides by dx, so that we'll have dy 2y over dx is equal to dx negative 2x over dx. So this can cancel this. Here we now have dy dx. So dy dx 2y can now be made, dy dx can be made subject of the formula, which means we're dividing both sides by 2y. dy dx can now be negative 2x divided by 2y. Remember, we're looking for it at 2 and 1. So this is x, this is y. So all we need to do is substitute. So dy dx is equal to negative 2. Instead of x now, we substitute it for 2 over 2. Y, instead of y, we substitute it for 1. So dy dx is equal to negative 4 over 2, which is negative 2. Let's look at this question. It says differentiate 3x squared plus 2y squared plus xy plus x minus 1 equals 0. Once again, this is an implicit function because you can see the dependent and independent variable on one side of the equation. So what we're going to do is differentiate this. This is not an issue. If we differentiate it, 3 times 2, 6x. So 6x dx. Now plus, we differentiate this, 2 times 2, 4, 2 minus 1, 1. So 4y dy. If we differentiate this, how we differentiate this, because we have x and y together, we're going to differentiate x, keep y constant, and again keep x constant and differentiate y, like this. If we differentiate x, we're going to get 1 dx. So let me just write it in this particular one, 1 dx, while we keep y constant, plus we now keep x constant and differentiate y, which is 1 dy. There is no need actually to be writing 1 dy because it is still the same thing as dy. So the next thing we can do is differentiate x, which is 1 dx. Differentiate a constant, you have 0, then equals 0. Now we can just simplify it, which is 6x dx plus 4y dy plus 1 dx is the same thing as dx, y plus 1 dy is the same thing as dy plus 1 dx is the same thing as dx equals 0. Now let those that have dy come on one side, which we have 4y dy plus, here there is dy also, x dy. Then the rest that doesn't have dy that have the x, let them go on the other side, and they will now carry minus. Their signs will change. Minus 6x dx, then minus words other dx dxy, or y dx. Let me write it as y dx. Okay, let me write it as 4y dy plus x dy equal to minus 6x dx minus y dx. So this is a proper way to write that. So now, so that you don't think that the dy belongs, that the x belongs to this also. So this is the proper way to write it, y dx. Now on here we have the x, so still minus the x, now equals 0. All right, equals 0 has now been cancelled. Now here we have dy, here we have dy, so we can factor dy out by saying dy into 4y plus x, so that if we use dy to multiply back, we'll get back this. Dy times this will give us 4y dy times this will still give us back this, which is equal to we can also factor the x out. If we factor the x out, because it is here, it is here, it is here, we'll have minus 6x, also minus y, and also minus 1, so that the x times 1 will give us back the x. All right, now the next thing is now to divide through by dx, so that we can get what we call dy dx. So dy dx 4y plus x is equal to, here the x, also the x, into minus 6x minus y minus 1, so that this can cancel out this. We have that dy dx is this, so that if we now make dy dx subject of the formula, we will divide through by 4y plus x. So we'll have minus 6x minus y minus 1 all over 4y plus x, and when we check, nothing else can go, so this is dy dx. So let's try this question now. It says differentiate 4x squared y squared plus x squared plus y squared equals 4 at 2, 1. Now you feel free to pause the video and try it yourself. Okay, if we start, how we deal with this is keep y constant while we differentiate x, and again keep x constant while we differentiate y. So if we keep y constant, we'll have the y squared constant. Then if we differentiate this, we have 8x dx. That's what we're going to have. Then plus, we now have to keep x constant while we differentiate y. So we will have 8y dy. 8y dy. So plus, if we differentiate this, we get 2x dx. Differentiate this, we get 2y dy. Differentiate this, 0, because it is a constant. The next thing we need to do is to take those that have dy to one side. So we will have, let's rearrange this so that it will make sense. So let's have 8x squared y dy, so that y and dy will be close, plus 2y dy equal to, these other ones are now coming over and they will now change their sign, so which is negative 8x y squared dx, negative 2x, that's this, dx. The next thing we can do is to factor out dy, since it is common in both. Dy into 8x squared y plus 2y, so that when we use dy to multiply them, we'll get back all of this. Alright, equal to, we factor the x here, so that the x, since it is common, so we have the x into negative 8xy squared, negative 2x. So the next thing is to divide through with the x, and if we do that, we'll have dy dx, then this 8x squared y plus 2y equals dx dx negative 8xy squared minus 2x. This is because this can divide this and we can have dy dx. Now we have that dy dx will now be equal to divide all through with this. So we'll have negative 8xy squared negative 2x all over 8x squared y plus 2y. Now remember from the beginning of the question they said at 2, 1. So what we can do now is say that dy dx is equal to negative 2. The first one is x, this is y. So anywhere we see x, we replace it with 2. Anywhere we see y, we replace it with 1. So this is x, which is 2, times 1 squared minus 2 times 2 all over 8 into 2 squared, then times 1 plus 2 times 1. So dy dx is, here we have negative 16. Sorry, here is 8, because looking at it, 8, negative 16, negative 4 all over 8 into 4 plus 2. So dy dx is negative 20 all over 34. You can still split it, negative 10 over 17.